I know the time is short, but let's just quickly say if we wanted to use more shareable changes, how would it look like if I was actually, like when we actually work on the system, how does it actually look when we're doing the real development? Okay, so what we would do is we would go into let's say that we want to make our own modified version of an SSP. So I want to save these changes. I want to make a Niels modified SSP 370. Let me go and do that. And the way that I'm going to do that is I'm actually going to go into that in the version control, in the MZ structure. I'm going to create my own copy of the JSON file, and I'm going to put my changes in there. And that's going to provide the functionality that Paul was talking about, where I can see my changes relative to the default. And we can also reuse it and share it. I see Ivy has a question.
Yeah, sorry, Neil, I was just wondering about the source mods, source modifications. So when you make the change, are you copying over the entire code locally? So this kind of ties back to Paul's question as well, but I guess I was wondering if there's like a separate designated folder for the changes that you're just running. I know you mentioned something about the model versions that uh, the version control that basically if you wanted to run it systematically, but if you wanted to run it just for a particular run, just for one simulation, do you copy this locally into a directory or?
So when we did the MZ setup, it did that. So you can see my screen, right? Like I'm literally in that directory for the run that we set up. If I list that directory, there is a subdirectory called CANESM. This is 100% of the CANESM source code and infrastructure code. Everything is in there. Now, if I say get status, it will tell me that Niagara is a very slow machine, apparently. Okay, no. So I've modified CANAM, CD CANAM, get status. Oh, I changed that file. Okay. This is just version control workflow. Get diff. Oh, look, I put in a times 100 in there. This is how you just would find it. So I don't have to do anything special. You don't have to use version control like this if you don't want to, I guess, for a one-off modification, but I would kind of recommend it. But all I did was change the code in what was cloned down for me. I didn't have to do anything special. I didn't have to tell it anything special. All I have to do now is MZ build, MZ submit, and it will use this change. So yeah, you don't have to explicitly make a copy. You've already got your own copy through the setup command.
Okay, I see. This is different from the type of setup that I'm used to with CESM. So,
Right.
okay.
Yeah, we have a very particular way of working. And so, but we have found that it serves us quite well doing this kind of, yeah, we basically provide people a full copy of the code. They can modify it, but then, yeah, if you want to send it back, there's a process for doing it. Okay, I do want to show quickly what that process is. So yeah, people can work through it at their own pace, but basically what we're going to do is we're going to go into that CANESM directory that we're just looking at. We're going to go into mzconfig experiments. I'm going to make a new directory called user experiments, and I'm going to copy the default CMIP6 SSP370 into my own version of that file. So let me just show you a little bit what this looks like. So there's the CANESM directory. I don't care about CANAM. I want to look at mzconfig experiments. There's CMIP6. Right now, there's an experiment definition for 370, and this is what that experiment definition looks like. This is literally the contents of that JSON file that defines that experiment. What I want to do is copy this. So I'm going to find the closest experiment to the one that I want to change. I'm going to copy that into my own experiment name, and I'm going to modify it. So that's precisely what's happening here. So let's just make a copy. I'm going to create a new directory and make a copy of that file. Okay, so should have done it. Let's see, mzconfig, CMIP6. Wait, I'm confusing myself. Did you do this? Oh, I have to, it's because Niagara is so slow. I have to reload that, I guess. Okay, so you can see now that there was CMIP6 experiments, but there's also NSWAT experiments. And I've got this copy that I've made of this file, which is called mzx config nswart. Okay, so, I could name this in a different way, but that's just how I chose to do the naming here. So, okay, so now I've got my own definition of this file, and now I can apply any changes that I want to this file and save them for later reuse. So I can't remember what it was I recommending. Okay, modify the file as needed. Okay, so let's say that I'm going to say, oh, okay, I always want to end this experiment in 2020. I don't want to run it longer. I could change the default, to that 8 that we used before, and I could apply any other settings that I wanted here. For example, I could come in and put that solvar change is equal to false or anything like that. I could apply those modifications. I could change that greenhouse gas file. I could make whatever modifications I wanted to make. So let's just make those 2 for now. And then what I would do is I have to use that kind of process that Clint talked about using the S commands to add and commit those changes. So this is pretty like regular Git stuff, although it's kind of like a little bit on the advanced side of Git. But that's basically what this block will do when you look at it in your own pace. So it'll go into there, it'll create a new branch, it'll add the changes to that branch, it'll commit them saying I'm adding a new SSP experiment, and then it's going to actually push those branches up to my fork. So I'm just going to execute that. It's going to do it. Oh, I'm in the wrong place. Am I not? Oh, am I not in the right repository? Oh, I see. Okay, so basically that will push the changes up to where we were before. I think I have to manually tell it to go here. Sorry, I interrupted that code block, which is why it broke. So I'm just going to force it to go there manually. Live demos. Okay, so it's going and it's doing all of that stuff, and it's pushing it up to GitLab onto my own fork of GitLab. And so I know that's kind of fast, but this is what is described in the user guide. And if I literally went onto GitLab, and I went on to like GitLab.com, and I went to my users, my fork, so nswart, and I went to CANism. Oh, of course, 2-factor authentication. Oh no. Okay. Well, I could actually see that code was then present on my GitLab instance. And so the advantage of working like this is that then if later I wanted to redo that run, I could literally just come and point towards my GitLab repo nswart, and I could tell it that I want to use this experiment, Neil SSP370, and so it would set it up the correct way every time. And I could go in and I could compare, my defaults against that one. So sorry, I think we kind of have run out of time for it, but that is kind of the idea of doing it, and we can unpack that more, I guess, in future times. So yeah, okay, that's what we could do with the practical time constraints. Christian.
Just very simple question. Did I understand that correctly? Every time you run CANism, it will first automatically by default recompile the code, regardless if you did a change in the source code or just in the JSON file or whatever?
Exactly. So that's how we operate. So what we do is we clone the full source code every time, and we compile. We do a full build of every single thing that is executed under that model is built from scratch every time. In our system, we don't compile third-party dependencies. So we don't compile like netcdf or ESMF. that are third-party libraries. And obviously we don't, create a whole new virtual machine or something like that. But in terms of like, there's a separation between what does the machine provide and then where does the CCCMA software stack begin? And for where the CCCMA software stack begins, we literally compile everything. And that's how we ensure like things like reproducibility and also like portability.
Yeah. Sorry. Also, I just want to clarify on that. If you do just change the JSON file and don't run IMSI build, you don't need to run IMSI build again, but IMSI build needs to be ran at least once for every run. But if you don't change the source code, you don't need to run IMSI build again, and it won't recompile.
Okay.
There's a question. Yes, so the notebook is available. Okay, yeah, someone has it. Great, thanks. Ivy.
Yeah, Neil, I was just wondering, you mentioned 6 different CMIP experiments that are available. If we wanted to run an experiment that isn't one of the 6, and if we specified the configurations, would it start downloading the files online, or are we just not able to run those at all?
No, so if you want an experiment that isn't in that list that I put up on the slides, then you have to go to a CP4C meeting and submit, could we please have this experiment? And then we will manually add it, because at this point we have to manually add it. And that includes putting the IMSI, like we have to translate our internal configuration to an IMSI configuration, like into one of those JSON files. But of course, we also have to make sure that the files are available on Niagara. So yeah, it's not like CSM where you just say this thing and then it downloads it. I mean, we could get there, but right now, no, there is you have to just basically ask for support for a new experiment.
Okay, I see. And I have another question, sort of more general, is so there are some other common modifications that we can make, for example, that others might be interested in, like the frequency of the restart runs that you'd want to output, or the frequency of the output files, if you wanted to change that, or if you wanted to add something to the name list that isn't already there. If we wanted to make these different types of changes, do you think that maybe it would be useful to have like something documented that or like a video tutorial to walk people through these common changes?
Yeah, so I guess the comment on that is that the model is set up to run in a kind of pretty common configuration that's quite usable. Some of those things that you mentioned might be easier to change, and some of them actually have a lot of implications, and it's not necessarily easy to change.
Mhm.
So that's where we're starting to get into more of that. Like today, I would say we did basically like the basic content, and then we started going towards intermediate. We haven't gotten towards any advanced kind of content yet. So yes, in a future workshop or when we have more time, yeah, we should talk about those different changes. But right now, the way that the system is set up, you run the model in 1-year chunks, and the diagnostics follows up in 1-year chunks. And it's not going to be trivial at this instant to change that. Of course, as we move forward in the future, yeah, we'll introduce more flexibility. But it's almost everything in CCCMA that we run the model in 1-year chunks, and we run the diagnostic in 1-year chunks. So, in terms of outputting different frequencies and stuff, that's not really also the way that, at least in the ocean, that's fairly easy. In the atmosphere, it's not that easy. And the atmosphere just puts out a lot of data by default, and you can choose what you preserve or what you don't preserve. But fundamentally changing it upstream is not something that's super easy. I mean, it depends on the details of what we're talking about, but yeah, that's when we have to start entering into conversations, yeah, with people like Deji and Jason in the atmospheric group and so on.
Right. Yeah, I think we played around with this idea in previous CP4C meetings, but maybe if we could propose specific changes kind of one by one and kind of discuss them in terms of like what would be useful to the community, frequently asked questions, then those might be more worth creating like a video tutorial or some sort of documentation for it, because these questions will keep coming up, I guess.
Yeah, and just for the functionality too. Like if it's like all these users want to be able to do, you know, this thing differently. Okay, well then we should just make that kind of like a default option that you can just flip with a switch. Yeah,
Right,
I agree.
right.
So yeah, I agree. Just like we have to accumulate those things in the CP4C meetings and we have to prioritize it with the time and resources available. What of these things do we tackle, right?
Right, yeah. Thanks.
Cool.
Just to follow on to that about, you know, like understanding what the priorities are. Part of it is to really appreciate like the default configurations you've already included and to see what we can do with those things. I think this is something you've said before, Neil, and I like coming back to it, that there's actually a lot you can do, and then there's also quite a lot you can't do. And sometimes we can just tweak what we want, tweak what our requests a little bit, and actually, or whether it's diagnostics or output, and get closer to what we want. So so that's why it is worth like being responsive and then also really considering. Like it's a combination of listening and also like mulling over things a bit to make sure we're setting our priorities right. And there's another point that I just wanted to mention, and that is that CanESM, like Can-Am, has this long history we talked about yesterday. And one of the things about the RTD and those diagnostics is that they're very close to the model numerics. Like there's a lot, like those like the energy budgets and everything are like really reflecting deeply like conservation properties in the numerical methods. From what I remember of this code sort of back to when I was a grad student even. And so there's actually a ton of value added buried in those in the current Can-Am output that we could actually take advantage of, and that would be like eventually lead to some good diagnostics. Things like the wave activity fluxes and all the detailed things that are calculated. So, and that stuff seems to be not very well documented, but it's there. And so, or maybe it's well documented, but it's sort of the documentation is a little obscure, the naming is obscure, and so on. So I think we should sort of make sure to have this part of this effort be to appreciate learn about what's there. And that might actually go a long way to giving us new opportunities to analyze the model in different ways. So this is a long-term issue, but it's something that I'd like to really get to know Can-Am and see what's already there. Like there's an ISCIP simulator in Can-Am. Like there's all sorts of stuff. That's just one example, but there's even older stuff that actually is pretty good. So.